Hello, future civil engineers. I'm back with a new example sa fluid mechanics. Medyo natagalan lang tayo mag-upload ulit ng bagong video, no? Naging busy talaga sa finals and sa full-time work. Okay? So, again, this is continuation ng topic ko about the buoyancy. So, if hinahanap niyo yung derivation ng formula natin, yung basic concept about buoyancy, so search nyo lang dito sa channel ko yung buoyancy part 1. Okay, so example number 2. Okay, so in this case, in this scenario, ang goal is to determine whether a crown sa pure gold. Okay, so was it pure gold? So paano natin malalaman if makuha natin yung specific gravity. Ito yung known specific gravity ng pure gold, 19.3. Okay? So, if yan makuha natin, then we can conclude na it is a pure gold. Okay? So, ano daw ang ginawa? So, it was measured on air. So, wala yung typical na pagtimbang. Okay? So, nakuha siya na 11.8. Then, nung nilubog siya sa water, so, ang naging timbang niya na lang is 10.9. So, yung setup natin most likely is ganito, no? Let's say, ito yung crown. Then, meron siyang scale. Okay, nakasabi sa dyan. Okay, then, so, tinimbang sa air. So, meron tayong reading dito na 11.8 Newton. And then, yung second scenario is, inilubog siya dun sa, okay, so inilubog daw siya sa water, then nung nakasabil pa rin siya dun sa yung scale. Okay, so nakuwang reading na lang is 10.9 Newton. So nabawasan siya kasi, so somehow na bigyan ng support itong crown, okay, ng ating buoyant force. Okay, then yung buoyant force, as we know, is equal to the specific weight of the liquid, kung saan siya nakalubog, in this case is water, multiplied by the volume displaced. Okay? And based dito sa figure natin, so of course, meron pa rin yung crown natin, yung talaga actual weight niya, no? So, hindi naman nabago. Okay, so yung pa rin naman yung weight niya, which is 11.8 Newton. So na yung reading is nabawasan lang dahil nga merong upward force, which is in buoyant force. So we can say that yung in this figure, yung buoyant force natin is equal to the weight in air, okay, minus nitong yung weight submerged. Okay? So, if we take the summation of forces, so bakit ganito? Kasi if we take the summation of forces along the vertical equilibrium, then that is 0. So, if we take upward to be positive, okay, then buoyant force, then meron tayong ano dito, di ba? Itong tension, itong reading natin is actually going up. Okay, 10.9 Newton, or yung weight, yung reading natin ng weight submerged. Okay, then minus nung weight in air. Ayan. So, kaya nakuha natin to. Okay, so paano natin solve itong problem? So, actually, mayroon tong formula sa laboratory. Okay? So, yung mga bagong estudyante, malaman hindi naman tayo nakapag-laboratory this school year so far. Okay? So, kung umabot tayo doon, so merong formula doon na yung specific gravity ng object is equal to the weight in air over weight in air minus weight submerged. Okay? So, titimbangin mo muna siya na nakaangat lang. Okay? May reading ka. And then, ilulubog mo siya sa water or any liquid na known yung specific weight or specific gravity. Okay? Then, kuha ka ng bagong reading. So, ito yung weight submerged. So, ito na yung formula natin. Pero, maya na natin yung gagamitin. And maya natin derive kung bakit yan yung formula. Okay. So, paano natin kinukuha yung weight ng isang bagay? Diba, yung specific weight or unit weight, diba that is equal to the weight over volume. Then, solving for weight is specific weight times volume. So, in terms of specific gravity, then the weight is equal to specific gravity times specific weight ng water, okay, times the volume. Okay? So, solving for, if kukuha tayo ng equation para dito sa weight in air, okay, so of course, this is not applicable sa weight submerged. So, sa weight in air lang to. Okay? So, yung weight in air is equal to yung specific gravity ng crown is equal to the specific gravity ng crown, unit weight or specific weight ng water times the volume of the crown. Okay? And sabi nga natin kanina that the buoyant force is equal to the specific weight of water times the volume displaced. So in this case, yung ating volume displaced is yun ding ating volume ng crown. So, meron tayong value nitong weight ng crown, weight in air. Ito yung hinahanap natin ngayon. Then, of course, known naman to, yung weight ng specific weight ng water. Then, unknown itong volume ng crown. Pero, daling dito sa equation na to, okay, so we can solve for the buoyant force. So, meron tayong weight in air, meron tayong weight submerged. So, we can solve for the buoyant force. Okay. So, if we substitute this dito sa equation natin, so we can say na yung weight ng crown is specific gravity ng crown multiplied by the buoyant force. Okay? And yun nga, buoyant force is weight in air minus weight submerged. Okay, so alam na natin yung weight ng crown. Okay, so that is 11.8 Newton. Then this will be equal to, substitute natin ngayon yung, or ilagay natin yung specific gravity ng crown, which is yung unknown. And then, buoyant force is yung difference nga nitong dalawa. So, saan ba equal to? Diba ang weight in air is 11.8 Newton minus 10.9 Newton. So, we have 0.9 Newton. Okay? So, that's the buoyant force. Okay, so multiply by 0.9 Newton. Okay? So, we can also solve for the specific gravity of the crown. So, which is 11.8 divided by 0.9. Okay, so we have 13.11. So, was it pure gold? So, no. So, not pure gold. Okay? So, etong formula na to, so, dito na rin yan nanggaling Etong kung i-derive natin dito, no? Itong equation na to. Okay? So, solving for specific gravity ng substance or material. So, that is yung weight. Diba itong weight nitong crown is yung weight in air over, nire-arrange lang muna natin, no? Ito. Specific weight ng water times the volume ng crown. Okay? Or yung volume displaced. And then, galing nga dito, sabi natin that etong mga variables na to, yung weight in specific weight ng water times the volume is the buoyant force. But, yung buoyant force nga natin is weight in air minus weight submerged. Okay? So, doon ang galing yung equation. Okay, so this one is, quite easy. So, medyo step up tayo ng konti. Baba natin to. Next problem. Okay, so a piece of yellow pine wood. So, given the specific gravity na 0.65 para sa wood. Then, 5 cm square. Yung cross-section niya. Length is 2.2 meters. So, ano yung 5 cm square? So, parang na-discuss ko na yata to sa ibang videos ko. No? So, madalas kasi nalilito dyan yung mga students in my experience sa teaching. Okay, so 5 cm square. And minsan, yung ginagamit naman is, so, may baguhin lang natin ng konti, no? 5 square cm. So, paano natin yan ita-translate sa number? Ano ba dyan ang area? Ano dyan ang side lang na kailangan pang yung square? So, yun lang naman yung magkatabi. So, 5 cm. So, definitely hindi siya area. Ito, 5 square. So, alam mo kagad na this is naka-area na siya. So, meron ka ng 5 square. So, anong side ng mga square na yun? Anong length ng mga square na yun? So, centimeter. Okay? So, this is 5 centimeter square. Okay? For 5 square centimeter. Okay, dito naman is, so yung nakakalito, 5 centimeter square or 5 square centimeter, diba? Ito naman is 5 centimeter. Then, 5 centimeter siya ay square. So, meron ka lang isang square na ang, well, equivalent lang naman. Not necessarily na talagang square siya, diba? So, we're talking about area. So, 5 centimeter. Pero 5 cm pa lang siya. Side pa lang yan. So, kung kukunin mo yung area, so kailangan mo siyang i-square. Well, this one is 5 square. So, alam mo na meron ka ng 5 square. So, area na kagad siya. Okay? So, that's equivalent to 5 cm raised to 2. Okay, so yung difference. So, ang given sa atin ngayon is this one. So, kailangan pa natin siyang i-square para makuha natin yung area. Okay? So, i-erase ko lang to. Okay. So, meron daw nga tayong wood. Naging green. Natin black. Ayan. Okay, so meron tayong wood, then, so since mas magaan siya sa water, so lulutang siya, no? Okay. Then, para lumubog siya such that 30 centimeters na lang yung nakalabas dito sa, okay, yung naka-protrude dun sa water level, sa water surface, 0.3 meter, 30 cm. Okay, then this is 1.9 meters. And so, lalagyan daw siya ng lead dito sa dulo. So, regardless ng shape ng lead. Okay? So, kung cube man yan, circular, oval, so any shape naman. So, regardless ng shape na. Okay, so, lalagyan siya ng lead. Pabigat. Para medyo mas lumubog pa siya. Okay. So, lalagyan nga daw ng lead sa dulo with a specific gravity of 11.4 yung lead. So, ang hinahanap is how many newtons. So, yung weight. Okay? So, ano daw yung weight ng lead in Newton. Okay? Baka lang ito ng konti. So, ito yung ating hinahanap. So, tingnan natin ano-ano yung mga forces involved dito sa system natin. So, meron tayong, of course, meron tayong weight ng wood. Then, syempre, meron din tayong weight ng lead. Then, since etong lead is nakalubog sa water, so, meron tayong buoyant force acting sa lead. And, dito sa nakasubmerged na portion ng wood, so, meron din tayong buoyant force ng wood. Okay. So, let's solve muna yung mga forces na yan. Okay. So, let's start with the weights. So, yung weight ng wood, so, sa kanina example natin, weight is equal to the specific weight ng wood, specific gravity ng wood, times the specific weight or unit weight ng water times the volume ng wood. Okay? So, this is 0.65 times the unit weight of water. Then, yung volume ng wood is 0.05 meter square. Okay? Times the length na 2.2 meters. Okay? So, sagutan natin ito mamaya. Then, para naman sa weight ng lead, so specific gravity ng lead na 11.4 multiplied by the unit weight of water, then yung volume ng lead, which is unknown. Okay? And then, let's proceed sa mga buoyant forces. So, yung buoyant force para sa wood is equal to the specific weight or unit weight ng water. Okay, so, hindi ko muna nilalagay yung mga numerical value. No? So, anyway, sa calculator, if ever man na kailangan natin ilagay, so, alam naman natin yung value nito. So, para hindi rin masyado mahaba. Okay, so specific weight of water times the volume of wood na nakasubmerge. So, that is, yung cross-section natin is 0.05 meter, then square. Multiply by the length na 1.9 meters. Okay? Then, lastly, para sa buoyant force acting doon sa lead, so, unit weight ng water times the volume of lead. Okay. So, if we look at this figure, so if we take the summation of forces, dito na lang, take the summation of forces along the vertical, and that is in equilibrium, so 0, yung summation of forces natin. And if you take upwards to be positive, then buoyant force acting sa wood plus buoyant force acting sa lead minus weight ng wood and minus ng weight ng lead, then this will be equal to 0. Okay, so yung buoyant force ng wood, hindi pa pala natin nasa-solve, no? Solve muna natin. So, 0.65 times 0.05 square times 2.2. Okay, and then yung sa wood naman is buoyant force ng wood 0.05 square times 1.9 meters. Okay, so this is 0.3575. This is cubic meter, no? Kasi volume to. Dito siya nanggaling. Ito walang unit. Multiplied by the unit weight of water. Okay. Then dito naman, sa buoyant force ng wood, so we have 0.00475. This is also volume multiplied by the specific weight of water. Okay, so substitute natin yung mga values. So, buoyant force ng wood is equal to 0.00475 meter cube multiplied by the unit weight of water plus buoyant force ng lead. So, unit weight ng water, volume ng lead. Minus ng weight ng wood. Ito yun. 0.003575 cubic meter times the volume of specific weight of water. Then, weight ng lead rather is 11.4 times the unit weight of water times the volume of lead. Then this all will be equal to 0. Okay, so lahat merong unit weight ng water, so we can cancel that out. Okay, then yung unknown na lang natin ngayon is the volume of lead. So we have to solve muna sa volume ng lead. Then, pag meron na tayo nito, so we can use this equation to solve for the weight. Okay. So, volume ng lead, combine na natin tong dalawa. So, pwede na kayong actually mag-shift solve, diba? Pero, i-simplify ko itong sa akin. So, yung 0.00475 minus itong 0.003575 is 0.001175 cubic meter. Then this will be equal to, so pag transpose natin ito sa kabila, 11.4 times the volume of lead minus volume of lead, 11.4 minus, so parang meron tayong 1 dito, no? Okay? So that will be equal to, kapag transpose natin, so 10.4 na lang. Okay, so binawasan natin ng 1, itong 11.4. Okay? Times the volume of lead. So, may unit pa ba itong 10.4? So, kung titingnan natin dito, yung 11.4 is nanggaling sa specific gravity, which has no unit. Okay? So, dito naman, wala din kasi ang unit natin is nasa specific weight ng water and nandun sa volume ng lead, which is invariable. So, yung 1 dito is wala ding unit. Okay? So, ito rin naman natin na if we solve for the volume of lead, ang may unit is etong nasa left side ng equation, 0.00175 cubic meter divided by 10.4. So, ang unit natin is, so tama lang na naka cubic meter. Okay, so let's divide this by 10.4. Okay, so this is equal to 1.1298 so on times 10 raised to negative 4 cubic meter. Okay, then solving for, medyo wala na ako ng space. Ayan. So dito na lang. So solving for the weight of the lead, then this is 11.4 times specific weight ng water, 9,810 Newton per cubic meter. So, Newton, no, kasi yun ang hinahanap dito sa problem in Newton. Times its volume na 1.1298 so on. Times 10 raised to negative 4 cubic meter. So, we can cancel out cubic meter. So, ang unit natin is in Newton. Okay, so 11.4 times 9810 times itong volume. Okay, so we have 12.635 Newton. Okay, so that's it for this video. So meron akong nakita nyo na din tong kita nyo na naman itong next example ko. So this will be for the next video na lang para hindi masyadong mahaba yung video natin for today. Okay. So yan, so if you like this, kung nagustuhan nyo itong video, paki-like. Kung tingin nyo nakatulong sa inyo, please consider subscribing sa channel para ma-support natin. And so please support my channel. Okay? And I'll see you on our next example.